Hello students, welcome back. So in this session, I'm going to be talking about determinant and inverse of a square matrix. So sometimes you have to calculate determinant or inverse of a square matrix. So NP, linear algebra, that's the library. Okay, this actually gives you these methods, these inbuilt methods. Okay, so why do we need a determinant? What's the purpose of that? Sometimes we want to know if a matrix is invertible, meaning we can find the inverse of a matrix. And the only way we can figure that out is if we know that the determinant is non-zero. So if it's a non-zero determinant, that means the matrix can be invertible. That means you can find the inverse of that matrix. And I'll explain you in a minute what do I mean by inverse. Okay, sometimes we have to solve this equation. Let's say you have an equation like this. This is a linear equation, and you want to solve this equation. In order to solve it, you want to make sure that your determinant is not equal to 0. The only way you can solve this equation if your determinant is not equal to 0. Okay, that tells you that the system has a unique solution. If, on the other hand, your determinant is equal to 0, that means the system is singular. Either it has no solution or it has infinitely many solutions. And sometimes you apply linear transformations to a 2D geometric shape. So in video games, or when they create video games, so you actually have to modify your 2D dimensional geometric shape. So this is where your linear transformation operation applies a lot. And so this is where you actually use this determinant. All right, so let's start with determinant. So first you want to do is import your necessary libraries. So these are the libraries I'm importing. I'm importing my NumPy as NP. I'm also importing this library, these two, okay, numpy.leanEdge. And I'm importing det and I'm importing inverse. Det is short for determinant and inv is a short for inverse. Okay, so let's calculate determinant of an inverse. Determinant of a matrix. So come over here, and this is my matrix. My matrix is 2, 1, 3, 5. This is 2 by 2 matrix, and we want to calculate determinant of that. And the answer would be, oh, I did not run this cell, have to run this cell, and then come back and run this cell. All right, so this is my matrix. Now, how do we calculate this, by the way? If you remember from your high school math, this was the process we used to use. Let's say this is your 2, 1, 3, 5. And so what we did, we multiplied 2 by 5. Okay, you see your 2 by 5. You multiply 2 by 5 minus, then you multiply 1 by 3. Okay, so 2 by 5 minus 1 by 3. And this 2 by 5 minus times, 2 by 5 minus 1 times 3. And the answer is 7. And this comes out to be 7. This is how it was done in the high school, and this is what it's done right now. Okay, as you can see, the answer is 7. So I just did the same one. Okay, 2, 1, 3, 5, and it calculated the determinant of this matrix. Okay, how about we want to calculate the determinant of a 3 by 3 matrix? Well, you can do that too. So this is my 3 by 3 matrix. Okay, and run this, and there you go. The determinant of this 3 by 3 matrix right here. Okay, I'm using this inbuilt method, determinant. This method basically I called over here, right here. This is that one. Okay, I'm calling that method, and I'm printing my determinant, and I'm also rounding it off. Okay, I'm rounding it off, and then I'm printing my result, and my answer is 12.0. So this is my 3 by 3 matrix, and the answer is 12. Let's calculate this by hand, and let's see if it gives the same answer. So come over here. This is the same matrix: 2, 1, 0, 0, 1, minus 1, 0, 2, 4. And the way you calculate determinant is, again, this is from a high school math, is 2. You start with this 2 right here, and then you go like this, and then basically you're left with 1, minus 1, 2, 4. So 1, minus 1, 2, 4, minus 1, minus 1. Then you take this sub matrix right here, subdeterminant right here, and then plus 0 times this, and the answer comes out to be 12. So the answer is 12. I'm assuming that you know the basics of how you calculate determinant from your high school. All right, and the answer is 12. So I just did manually. I went through the hand, and you can see your linear algebra gives you NumPy linear algebra library gives you this inbuilt method. Okay, what about the inverse? Sometimes you may want to calculate the inverse of a matrix. So this is your matrix A, and you want to calculate inverse of that. So let's just create few cells, come over here, paste it. All right, so this is my matrix A. Okay, I want to calculate inverse of that, and for that I'm going to call this inbuilt method inv. All right, this inv is the same this one right here, the one I just imported. All right, inv, and I print my inverse of my matrix. Then I'm also doing verification. Okay, and when I run this, it gives me my answer right here. Okay, so this is my inverse. This is my matrix right here, A. Okay, and this is the inverse of that. So how do we calculate that? Well, again, from your high school math, anytime when you have a 2 by 2 matrix like this, A, B, C, D, these are numbers. So inverse, if you remember, for 2 by 2 matrix is 1 divided by AD minus BC. All right, AD minus BC, and then you take this thing and this is your D minus B minus C minus A. Okay, this is your another matrix. So you take this factor and you multiply by this. All right, coming back to this, and this is what just happened, and this is how you come up with inverse of a matrix. Now, one of the property of your inverse of a matrix is that, if you remember, let's say I ask you what is the inverse of 3. Okay, that means 3 multiply by what number? The answer should be 1, right? You're going to say the answer is 3 minus 1, right? Right, that's your inverse. Well, what if I ask you 4? What is the inverse of 4, or what would you multiply 4 by? So the answer is 1. Well, you're going to say 4 inverse, right? Or you can say 1 over 4. So these numbers right here, they are called inverse, okay? Inverse of this number. And the reason they are called inverse, because when you multiply this by this, the answer comes out to be 1. Well, same thing happens in matrix. So if you have a matrix A, you multiply A by A inverse, all right, so that you get this 1. Now in matrix, 1 basically refers to identity matrix. I'm assuming you know what identity matrix is, okay? If you don't, then refer to my previous NumPy tutorials and I explain these identity matrix. So every matrix has an inverse, okay? And you take this, you multiply A by inverse, and that should give you identity matrix. So this is the way you can verify whether this matrix is an inverse or not. So first of all, what I do, I find my A inverse. This is my A inverse. Okay, this is my A right here. This is my A matrix. All right, and I calculate my A inverse right here. And I print it out, it prints out over there. Then I do verification. Okay, now if you remember, how do we multiply two matrices? We use this symbol, A at A inverse. So basically this is a short notation of multiplying two matrices. So I'm multiplying A by A inverse. Okay, I multiply A by A inverse. All right, and the answer should be 1. If the answer is 1, then we know our A inverse is right. And sure enough, that's what I'm doing over here. So if you look over here, I'm taking my A, I'm multiplying by A inverse. Okay, this A inverse, and then I'm rounding it off. Okay, I'm rounding it off, and then I print my result. And look at that, it comes out to be identity matrix right here. Now, identity matrix are the matrix where all elements are 0 except the diagonals, and the diagonals are always 1. So you see the 1, 1, 1. So diagonals elements are all 1, and rest of the elements are 0. That's what your identity matrix is. Okay, identity matrix. So we know that this is correct answer, because when I multiply A by A inverse, I get my identity matrix right here. Okay, this is this matrix right here. All right. Now, let's do the same thing for a 3 by 3 matrix. So I have a 3 by 3 matrix. All right. And let's find the inverse of that. Same process. Okay. This is the inverse of 3 by 3 matrix, that A. So this is my matrix A right here. This is my inverse of this matrix, A inverse, and then I verify. Okay, I multiply A by A inverse, and you can see it gives you diagonal. It gives you identity matrix. Everything is 1 along the diagonal, and rest of the elements are 0. Again, what's happening is that this is your A. This is your A. Okay, and this is my A inverse. Okay, this is my A inverse, and I'm multiplying A. This is the symbol for multiplication in NumPy. Okay, that's how they do multiplication right here. So A multiplied by A inverse. Okay, and my answer should be identity matrix. Okay, I could have write I over there. Some people they write I, some people they write 1 over there. So just thought you should know. All right, so A times A inverse is identity matrix right here, and you can see it is identity matrix right here. All right, and this is my A inverse. A inverse. All right. Then in application. So let's look at an application of these inverses. So let's say you want to solve an equation. Okay, this is the equation you want to solve. So You have an equation. It's a linear equation, and let's say the equation is this: 1x1, okay, let's call it x1 plus 2x2 equal to 5. You want to solve this equation: 3x1 plus 4x2 equal to 11. Well, first you find your A matrix, okay? Now, the way you find your A, you look at the coefficient of every single element. So in this case, the coefficient of x1 is 1, right? 1 times x1. So it's going to be 1, and this is 2, 2, okay? Then you have 3, 3, and then you have 4, 4. So this is my A. And my B, okay? My B is going to be this right here, these elements. Okay, so this is my B right here, 5, 11. So this equation can be written like this: A times x equal to B, right? And your x, by the way, your x can be written as x1 and x2. Okay, so this equation right here, this equation can be written as like this. Okay, ax equal to b. So what is the value of x? Well, x is going to be a inverse times b, right? This again from your school mathematics. So if your ax equal to b, that means x equal to a inverse b. So you just have to find a inverse, and we know how to find a inverse, right? We just did a minute ago. All right, so let's say this is your matrix A, right? This is my matrix A right here. This one, okay. This is my B. This is my B right here, which is this one. And then I calculate my inverse. Okay, this is my inverse. Once I know my inverse, okay, I know my B, multiply A inverse by B, that will give you X. Okay, that will give you a solution. So X equal to np dot mat mult A inverse. Okay, I'm taking A inverse, multiplying by B. Okay, and this is my X. Okay, so this is what's happening over here. This is exactly what's happening over here. And then I print my X value, and X is 1, 2. So that means my solution, X1 is equal to 1 and X2 equal to 2. So this is my solution right here. Okay, so this concludes this class. All right, gentlemen, thank you.